We're now going to look into some applications of exponential functions and logarithmic functions. And trust me, we're only going to scratch the surface. There are a ton of applications for these types of functions. Now, here we have a formula for population growth. It says the function p of t equals p0 e to the kt, where k is greater than 0, can be used to model many kinds of exponential growth, where k is the exponential growth rate. Now, it may look like a new formula, but you've actually seen this before. This is the same formula that we saw for continuously compounded interest. We're now just talking, instead of talking about a bank account and money, we're talking about a population growing. So we could be talking about people growing or bacteria growing or how a certain population of animals is growing. But if you let that population be your money, then this would be the exact same thing as continually compounded interest. We're just using slightly different letters. So instead of an interest rate R, we're using K, which is called the exponential growth rate. And we'll use that as a decimal again. But it's exactly what you've done. So problem number 1 here says, according to U.S. News, the population of the United States as of January 2014 was approximately 317 million. So that's going to be our starting population, our P0. The current growth rate of the population is 0.7%. So our K, which we want as a decimal, is going to be 0.007. So A says if the growth rate remains constant, write the exponential function, growth function for the situation. So we'd have P of t equals 317 million. We'll just put it in terms of millions, so we can just put 317 e to the 0.007t. So B says find the projected population of the United States 10 years from 2014. So we're going to put in 10 for t. So P of 10 would be 317 e 0.007 times 10. And we can put this in here. So 317 e to the 0.007 times 10. Here's, you don't actually want to close the parenthesis there or it'll finish the exponent and then multiply by 10. So don't put the parentheses exactly like I wrote down here. Down here, I understand that 10 is still in the exponent, but if you did that on your calculator, the calculator's not that smart. Okay, so I'm going to hit enter. And we see that we would, in 10 years, we would have about 339.99 million. Okay, and then part C asks, when will the population reach 500 million? So when is a time? We're going to solve for a time. So we want to know, when is it going to be 500 million? Well, that's going to be our kind of answer out. So we're going to have 500 equals 317 e to the 0.007t. Now, we did a problem like this when we were talking about continuously compounded interest, and we used our calculator. Now that we know how to solve logarithmic equations, we can actually do it without graphing. So the first thing we're going to do is divide both sides by 317 so that we get our exponential by itself. So we'd have 500 over 317 equals e to the 0.007t. Now remember, when we were solving exponential equations, we're going to take natural log of both sides. So we would have natural log of 500 over 317 equals, remember, natural log and e kind of cancel each other out, equals 0.007t. And now we're going to divide both sides by 0.007. So we'd have natural log of 500 divided by 317 divided by 0.007. And so we'd see that t is about 65 years. So if we're starting in 2014 and adding 65 years, right, we would expect for this to happen in year 2079. Okay, and then we're asked how long will it take the population to double? Again, here we're kind of talking about how many years. Now, if we started with 317 million, what is doubling? Well, it would be 317 million times 2. So it would be 634 million. We want to know when that will happen. So we're going to solve it very similarly. Now, the first thing we're going to do is divide both sides by this 317. We know that 634 divided by 317 is 2, so we have 2 equals e 0.007t. We're going to take the natural log of both sides. So we're going to have natural log of 2 equals 0.007t. We'll divide by 0.007. So in our calculator, we're going to do natural log of 2 divided by 0.007. And we'll see that it'll take about 99 years for the population to double.